Here we have a pre-calculus problem. Okay, let's go over the question. The graph of y equals to log of x positive c to the base b passes through the point 0, 0 and 3 over 2, 1 over 2. The value of the base b is. Okay, here in the given function, we have to find the value of the base b in the logarithm. Okay, and also the question says the graph of this function passes through the 2.0, 0 and 3 over 2, 1 over 2. Okay, let me take the given function as it is. That is the y equals to log of x positive c to the base b. Okay, so the first information says the graph of the given function passes to the point 0, 0. Since the graph of this function passes through 0, 0, I can plug in the x coordinate 0 for x over here and the y coordinate 0 for y over here. So let's plug in the y coordinate 0 for y and x coordinate 0 for x. Then I'll be getting 0 positive c over here. So 0 equals to log of b, so base b, and 0 positive c is simplified to just c. Okay, now what I need to do is I have to simplify this one. Actually, this equation is in logarithmic form. So I have to convert this equation to exponential form. So to convert this equation to exponential form, I have to move this logarithm with its base to the left side of the equation. When I move this logarithm along with its base to the left side of the equation, I have to ignore this logarithm. I have to consider only the base b on the left side. The value which already exists on the left side will become the exponent of this base b. So we have b to the 0th power. On the right side, we just have c. So b to the 0th power is just 1. So anything to the power 0 will result 1. So the value of this one is just 1. 1 equals to c. So now I got the value of c. Okay, now so the given function can be written as y equals to log to the base b x positive. We can plug in c is equal to 1 over here. Okay, now we have the given function y equals to log of x positive 1 to the base b. Okay, now to solve for b, what we need to do is we have to use the second point because the graph of the given function passes to the point 3 over 2, 1 over 2. So we can plug in this 3 over 2 exponent for this x and y coordinate 1 over 2 for y. So let me do it. 1 over 2 equals to log to the base b. So for x, we can plug in the exponent. That is 3 over 2 positive 1. Okay, so 1 over 2 equals to log to the base b. So when I combine 3 over 2 and positive 1, it will be just 5 over 2. Okay, now so again the equation is in logarithmic form. I have to convert this one to exponential form to solve for b. So for that, I have to move this log along with its base b to the left side of the equation. So when I move this logarithm along with its base to the left side of the equation, I have to ignore this logarithm. I have to consider only the base b on the left side. The value which already exists on the left side will become the exponent of this base b. Then I'll be getting b to the power 1 half equals to. On the right side, we just have 5 over 2. Okay, almost we have solved for b, but still I have to get rid of this exponent 1 half. So to get exactly what the value of b is, so I have to get rid of this exponent 1 half. So to get rid of this exponent 1 half, I have to raise both sides of this equation to the power of 2. So let me raise both sides to the power of 2. So b to the power of 1 half is raised to the power of 2. On the right side also, we have to raise 5 over 2 to the power of 2. Okay, here we have two exponents. That is already we have base b and the first exponent 1 half we have for this base b, and for this complete stuff we have the exponent 2. Okay, let's consider the power of a power rule in exponent. That is a to the mth power whole to the nth power. So whenever we have two exponents like this, so we can multiply the two exponents over here. Okay, the same thing we have over here. So we can multiply the two exponents 1 half and 2. So when I multiply them, I'll be getting b to the power 1 half times 2 equals to, and here we have an exponent for a fraction. So whenever we have an exponent for a fraction, the exponent can be distributed to numerator and denominator. Then I'll be getting 5 square over 2 square. So here 2 will cancel out. I get b to the first power. B to the first power is just b, and 5 square is 25 over 2 square is 4. Okay, when I divide 25 by 4, I'll be getting 6.25. The value of the base b and the given logarithm is 6.25.